So I asked you to review this lesson, but I would like to go through it. It's pretty straightforward. We're going to be in this unit talking about a couple of new type of functions. You guys basically have seen two types of functions. In grade 10, you did a lot of study on linear functions, as in lines. You learned how to graph them, given their equations. You learned some properties of them, like domain and range and y-intercept and x-intercept and slope and other things. And then you went back the other way. If I gave you a graph, you would be able to tell me the equation. Well, we did the same thing this year, except with quadratic functions, or the graphs that look like the graphs that are parabolas, or the functions that have an x squared in them. Okay. Next year, we're going to be looking at several different types of functions. Okay. And basically, what we're going to do with a lot of them is we're going to first of all, learn what the function means. Okay, like in this case, we need to understand what absolute value means in order to graph and state properties of absolute value functions. And then from there, from functions, we can go to equations, solving them. We're going to do the same thing in this unit with rational functions. Rational means fraction. So functions that have fractions in them, what do they look like? Okay, you already know how to solve, you already know how to work with rational expressions. We did it in the last unit. You already know how to solve rational equations. We did that in the last unit, but we haven't looked at rational functions and what they look like. The reason why we do so many of these different functions is because you guys are kind of getting to the point in math where the applications of these are starting to get very specialized. Okay? Will you see absolute value in your future career? If I was a betting man, I'd probably say no. Okay? Unless you were involved in, say, physics or possibly finance, then you might be. Okay? Will you see rational functions? Perhaps not, but perhaps you might. Okay, they all have different applications. So we want to look at a whole bunch of different types of them. So basically an absolute value, all that means represents its distance from zero. It's basically turning a negative number into a positive number. The formal math definition, we would say for any real number x, that means numbers that, like whole numbers, decimal numbers, fractions, numbers like pi that we can't write as fractions. Okay. The absolute value of x is written as x with a couple of vertical bars around it and is a positive number, with the exception of 0. Like how far is 0 from 0? It's 0. That's neither positive nor negative. Okay. So like if we talk about things like if we want to know the distance between two things and we're not concerned about direction, we would use absolute value. Okay. If we want to talk about debt in business, we can often use absolute value to help us express it, because you never say that you're in a debt of negative $100. You say you're in a debt of $100. Okay, so the actual debt is negative 100, but you would say it as 100. In other words, the absolute value of negative 100. So the absolute value of any positive number, well, that's easy. It's just positive. And the absolute value of any negative number is going to become positive. And the absolute value of 0, like I just said, is 0. So if I said the absolute value of 5, well, you're basically asking yourself, how far is 5 away from 0? It's 5. If I ask you the absolute value of negative 5, I'm asking you how far is negative 5 away from 0? The answer is also 5. Okay? So whenever we absolute value something, if it's, as long as it's not 0, it's always going to be a positive number. So these two ones are pretty straightforward. The first example, the absolute value of negative 12 is 12. And the absolute value of positive 7 is 7. That's it. You may, however, get expressions that you're asked to calculate that involve multiple absolute value bars, or other order of operations, or parentheses. So we have to be careful, and we have to apply order of operations. And the way you kind of apply order of operations with absolute value is you kind of treat them like parentheses, right? So like if you had an expression that had parentheses on it, you'd work inside the parentheses first before doing the stuff around it, okay? Same thing with absolute value. You do all the stuff inside the absolute value and then take the absolute value to make it positive and then work on that other stuff around it, okay? So we treat them like parentheses. It's not the same thing. When applying order of operations. Okay. So like if you've remembered BEDMAS or BEMDAS or PEDMAS or PEMDAS, okay? You always do parentheses or brackets first. Well, we kind of include absolute value bars in there. So for the first example, with all these examples, we have multiple operations. What would I do first? What's that? Really? So I do nothing with the first absolute value? Okay, so I'm going to do these two. Because remember, we work from left to right. So the absolute value of 3 is 3. I'm not touching the subtraction yet. And then I'm taking the absolute value of negative 8, which is positive 8. So I get 3 minus 8, which is negative 5. What would you do first in this one? 5 minus 2? 4 minus 2? Really? That's order of operations? You have to do the 7 minus 2 first. And when I do that, the absolute value bars are still there because I haven't taken it yet. Now the next step, I have to do the absolute value before doing the other stuff. So I have to do this next. So the absolute value of 5 is 5, but instead of writing absolute value bars, I put parentheses now because it's being multiplied by the 4. Now what? What's that? 5 times. Thank you. Nice and clear. Thank you. When I'm going like this, I can't hear you. And then 5 subtract 20 is negative 15. Yes?
Do we have to show this step where you
Not necessarily. I'm showing a whole bunch of steps here. If you show only 2 steps, that's fine. Okay? Okay, this one we got a whole bunch of stuff going on. So we've got absolute value bars, but then we've got stuff going on inside the absolute value bars. Well, the very last thing I'm going to do is times negative 4, because that's on the outside. And on the inside, I'm not even going to take the absolute value until I get an answer to all of this first. And what do I do first? The parentheses, right? So I get negative 3 times 2 minus 5 is negative 3 all squared plus 6. Still not touching this stuff. What do I do next inside the parentheses, or inside the absolute value bars? And what is negative 3 squared? Positive 9. And it's being multiplied by negative 3. Now you guys may want to skip a step here and just do all of this in one. Negative 3 times 9 plus 6, negative 21. Remember, we haven't absolute valued it yet. When I do take the absolute value, I have to put it in parentheses because it is being multiplied by the negative 4. So we get a final answer of negative 84. And finally, what numbers or expressions have an absolute value of 5? Negative 5 and positive 5, right? So I could say this equals 5, or that equals 5. I just did. Right. That means both. You can't say and. That makes no sense. Tell me what number is both negative 5 and 5?
5.
Okay.
The war is giving like it could be this, but it can also be this.
Right.
But you're saying, like,
Absolute value of negative 5 is 5, or and would work in this case, but not every case. Like if I, okay, here. No. That's a good question. I want you to tell me a number that satisfies this. Tell me a number that satisfies this, that fits this description. By the way, this says greater than. Number that's greater than 5 and less than 0. Anybody? Why are you saying that? Why is everybody hesitating? Why is no one talking? Because, right, because there's no number that can both be bigger than 5 and less than 0. Okay?
Yes.
No. 0 is greater than 5? Sorry? Why? Yeah, it could be this, or it could be this. So 6 works because it fits this. There's a big difference between these two words in math. Okay? It could be negative 6. Just be negative 6, no, it's not greater than 5, but it says this or this. It doesn't have to be both. Of course it makes sense. It's the logic part of math, and or, what they mean mathematically. Okay? So that's why I used or. Thank you. I didn't invent it, but thank you. And this would obviously be negative x.
Or
You're going to learn that in stats next year when we do probability. There's a big difference between and or. Or means we add, and means we. Oh, come on, you two. No, and means we. You too. Multiply. All you had to say was multiply. Don't base your answer on my looks. Okay? Don't make an excuse and based on my looks. Jeez.
I might, you know what?